Today we are going to discuss about Poiseuille's equation, that is viscosity. Under that there is another equation that is important and it has certain kind of questions, important parts. Actually here we discuss about how a liquid flows through a tube. That is the important part of this. Then there is a rate of flow. Rate of flow means how much of water in volume or in mass it really flows in unit time. That is called rate. But mainly Poiseuille said about volume per minute early, or that is the volume for unit time. Now SI units are used, therefore we are using volume for 1 second. That is a rate. Volume is measured in cubic meters. Anyhow, we'll start now. First of all, we'll consider the tube. The tube is concerned that tube is having internal and external diameters. So then that means you get internal and this is a cross section. If I draw the cross section separately, this is the outer surface. This is inner surface. This is R1. This is R2 normally. But in this case, we consider internal radius only. And it is denoted by normally simple A in that equation. Drop this. Internal. A is internal radius of the pipe or tube. This is important thing, internal radius. This part is very important. Poiseuille's equation normally equation. But before coming to the equation, there are some definitions. First of all, we'll consider about how the liquid flows. In the previous part one or the first one, I said always it flows from higher pressure to lower pressure. Here it is P1, here it is P2. Then it flows from higher pressure to lower pressure. Then there is a pressure difference. First you write, when a liquid flows in a tube, it flows from higher pressure to lower pressure. In this case, if it flows from left to right, or if the liquid flows from left to right, P1 is greater than P2. Left to right means A to B. Then pressure difference. That is equal to P1 minus P2. And pressure difference is denoted by delta P. Delta P is equal to P1 minus P2. Now, draw like that again and write up to this one. Length of the tube is considered as L, or we can say delta L if you want, delta L or L. Then we are defining another thing that is called pressure gradient. Another physical pressure gradient. Pressure gradient is defined as pressure difference divided by length of the tube. Then pressure difference is delta P, delta L. So therefore, pressure gradient is delta P over delta L. After that, we want to find dimensions. Dimensions of pressure gradient. That means pressure gradient is equal to delta P over delta L. Pressure difference dimension is pressure dimension M L minus 1, then T minus 2. Normally force is ml T minus 2 divided by area L square, then you get this pressure. So then divided by L. Then this is ml minus 2 T minus 2. When this L is taken up, L minus 1, brother, present L minus 1 is also there. Then L ml minus 2 T minus 2. After that, we want to find the SI units. SI units. SI units of pressure gradient. Again, pressure gradient is equal to delta P over delta L. SI units, Pascal or Newton per square meter, divided by again meter, delta L, then Nm minus 3. Or again, delta P is Pascal divided by M, then Pascal per meter. Both are correct. in certain cases, del pressure gradient or delta P divided by delta L. Sometimes it is written as P1 minus P2 divided by delta L. Even some places, some books, they use simple delta. P1 minus P2 divided by simple delta. Like that also it is there in some books. Note down. Poiseuille is a scientist who did certain experiments on flow in liquids in pipes. And finally, he gave us a certain equation. That is the one we are calling Poiseuille's equation. He derived it. This can be derived using actually dimension, theory of dimension. When a liquid flows through a pipe, internal radius A, the rate of flow we want to know. Then rate of flow of liquid. That is volume of the liquid, if you want write flows, divided by time taken. Simply we can say volume divided by time. So this is denoted by V over T. Rate is denoted by Q. So Q is equal to V over T. This is volume wise. Note down. That is volume wise. SI units. Q equals cubic meters divided by second. Cubic meters per second. Dimensions. Q equals V over T. L cube divided by T. L cube T minus 1. L cube T minus 1. In Poiseuille's equation, actually rate is given according to the volume. That means if you want, you can say rate of flow of liquid as volume. Yeah, as volume. But if you do not state that, that means according to volume. But remember, this is also there. Rate according to mass. So then rate of flow of liquid according to the mass, that is equal to mass of liquid flows, mass of liquid flows divided by time taken. So that means M over T. This is rate Q dash. Then we can consider about SI units. SI units, Q dash is equal to M over T. Then mass is kilogram, time is second, kilogram per second. Right after that. This is not involving Poiseuille equation. As simple as -1. Dimensions. Now, dimensions according to the mass. So, Q dash is equal to M over T. Then M is capital M. T is T. M T minus 1. But in the Poiseuille equation, this is not there. We are considering. Now I'll tell you how to convert. So sometimes mass per unit time is given. So we'll say it is given as Q dash is, example, Q dash is equal to M over T. Mass is in kilogram, SI units. This is in seconds. We want to convert mass into volume. For that, divided by density. But density should be in SI units. SI unit. Kilogram per cubic meter. Then Q dash is equal to M divided by rho divided by T. Then what happens is why the SI is considered, this is in M is mass, kilogram divided by rho. That means kilogram divided by kilogram per cubic meter. Cancel off. This is taken up. Then you get MQ. So then answer is cubic meters per second. So this is how you convert. Example, right after this. Example, rate of flow of liquid is 400 grams per minute. So Q dash is given as 400 grams per minute. That means 400 grams divided by 1 minute. So then 400 grams should be converted to kilogram. Then divided by 1000, now multiplied by 10 to the power minus 3. So then divided by 1000, now you get in kilogram, divided by 1 minute is 60 seconds. right? So then that value is now given as 400 divided by 1000 divided by 60 kilogram per second. I converted into SI. This is SI units now, right? Considering the liquid is water, then density of water is 1000 kilograms per cubic meter. Then Q is equal to 400 kilograms per second, kilogram divided by 1000 into 60 divided by again rho W. That means 400 divided by 1000. Then this 1000 is the density of water. So then divided by again 1000 into 60. Then 4000 divided by 1000 into 1000 into 60. 1, 2, 3, 1, 2, 3. So roughly 415. Then you can say Q is equal to 1 over 15,000. So units, here you get cubic meters per second. This is how it converts to Q. How Q dash converts into Q. Mass to volume. Note down. Yeah, I erased it. I think you have completed it. This is 1 over 15,000. Now, when a liquid flows through a pipe having internal radius simple A, and internal radius of simple A, and the length of the pipe is delta L. This is A, this is B, here P1, here P2. Then, as I told earlier, delta P is P1 minus P2. Then pressure gradient we can find, right? Here, what we have to do is, using dimensional analysis, we can prove this equation. But under this section, that means properties of matter under viscosity, now they don't ask you to prove the equation in this way. At the exam, they might say, using dimensional analysis, prove that this is correct. The equation is given. Then you consider left-hand side, right-hand side of the equation and equate the both sides dimensions. But anyhow, the proof comes under first unit. Anyhow, note it down. the rate of flow of a liquid through a horizontal tube under steady state. Steady state. Last time, the first video I have considered that state depends on. Now write the capital K within brackets. Depends on the internal radius of the tube within brackets A. The internal radius of the tube A. The coefficient of viscosity of the liquid flows within brackets eta, and the pressure gradient and the pressure gradient of the flowing liquid. Normally, pressure gradient is denoted by curl G. G is gravitation acceleration. So you have to understand delta P over delta L can be written as this. Within brackets curl G. Using dimensional analysis, we can derive the needed equation, and the constant K is equal to pi by 8. But remember, they don't ask this part under this unit. That's under first unit. Then, according to this, Q depends on. Q is the rate. Then depends on the internal radius, eta, and curl G, pressure gradient. Remember, using dimensional analysis, we can prove the equations when there are 3 unknowns only. More than that, we can't do. Anyhow, there are situations, here also I can explain later. If it is more than that, we have to categorize 2 or 3 together according to a particular meaningful manner. But I will explain it later. Before that, we'll start and do this one. Q is equal to, then we can say K A to the power X, eta to the power Y, and curl G to the power Z. Here, K is a dimensionless constant. That is a very important part to be written. Then dimensions of Q. L cube T minus 1 according to the volume. A, internal radius, L. Then eta, can you remember eta? ML minus 1, T minus 1. Then curl G dimensions. That is rate pressure difference. Pressure difference, we got it. How did we get? Pressure is ML minus 1 T minus 2 divided by L. Then ML minus 2 T minus 2. Then you can substitute these values there. Q. Q is L cube T minus 1. Equation 1. Then K L to the power X eta M L minus 1 T minus 1 to the power Y. And curl G, that is M L minus 2 T minus 2 to the power Z. Right, not down up to that point. After that simplification, L cube T minus 1 is equal to K Lx My L minus Y T minus Y multiplication of this. Then Mz L2 minus 2Z T minus 2Z. After that, take the same dimensions together, closer to each other. Lx, L minus Y, L minus 2Z, My, Mz, then T minus Y, T minus 2Z. Then L cube, T minus 1. I'll take here L cube T minus 1 is equal to K L. Then power is X minus Y. Then minus 2Z. L, there are three terms. M Y plus Z. Don't copy. T minus Y minus 2Z. Power. Normally we have to equate the powers. When you equate the powers, first we equate the powers. Here M is not there. In this case, M is not there means it is M to the power 0. M is not there means M to the power 0. So if you consider M, here you have to write by equating the powers of each dimension. Then you get first one M. Then 0 is equal to Y plus Z. First equation. Second equation we are taking from T. Then you get minus 1 is equal, here the power is minus 1, minus Y minus 2Z. Second one. If you add 1 plus 2, then minus 1 is equal to plus Y minus Z. Z is equal to 1. Z is equal to 1. Then from the first one, first equation, Y is equal to Z is equal to Y is equal to minus Z. So therefore, Y is equal to minus 1. Then I'm going to equate the dimensions of powers of L. L is concerned, here 3 is equal to X minus Y minus 2Z. 3 is equal to X minus 1 minus 2. Then you are getting plus 1 3 is equal to x plus 1 minus 2. Then 3 is equal to, can you see this? 3 is, I'll write at the top. 3 is equal to x minus 1. So x is equal to 4. When x is equal to 4, right up to this, then after that I'll write the other things. After that, what you have to do is you have to substitute here. Then there you get q is equal to k ax eta y and curl gz. So then here it is equal to k a x. X is 4. Eta is y is minus 1. J is curl g. Curl g is 1. Then right up to that, after that I will explain. Right, I'll continue from here. Now look at this. Here q is equal to k to the power 4. Eta minus 1 means here eta into g. Remember, g is curl g is equal to delta p over delta l, and this is delta p, and the other one is k. K is that was given by me pi by 8. Then q is equal to pi by 8 a to the power 4 divided by eta g delta p over delta L. This is called Poiseuille's equation. Always Poiseuille's equation is related to flow of liquid under steady flow through a horizontal pipe. But when applications are there, even it is slanted or vertical, we apply, but it is correct for when it should be a when it is horizontal and steady flow. Now anyhow, this equation can be seen in different ways. Q is equal to K a to the power 4 delta P over 8 eta A. Sometimes K value is not substituted. Right after that. In certain cases, delta P is written as P1 minus P2. So sometimes this is given as Q is equal to pi over 8 eta L, then a to the power 4 P1 minus P2 instead of delta P. Here, this L, some delta L here. Here, this L is instead of delta L considered as L. Instead of delta P, considered it as P1 minus P2. Normally, most of the situations, we are getting this equation. This is the most common equation what we can see most of the places. Calculation is sometimes seems to be difficult. Sometimes they say different questions are given. This is the tube. I'm not going to draw separately inner and outer. Always inner one I consider the tube. Now, there is an instrument called constant pressure head. Constant pressure head means that instrument can provide always constant pressure for the liquid. It's like this. It consists of just like a container. To fix it, there is a handle here. Inside, there are 3 tubes. One is just starting from the bottom. The other one is starting from the bottom of few centimeters above the bottom. And another one is there, but I'll draw this separately. This is gone to a certain height. And the other one is here. Now, we'll understand how it can provide or produce constant pressure for a liquid. Here we'll say from the tap, the liquid comes. You have to connect through the pipe. From the tap. From the tap. We'll say from the tap we get water. No? So it rises here and comes up to this level. When it reaches that level, excess amount goes there. So that means this is to be connected to where? Sink. Put into the sink. So wastewater like that. Then see, always there is a pressure here from the atmospheric pressure. PATA. This point is concerned. Now we are doing a practical. This is a horizontal tube. And the pipe is or the tube is connected. Rubber tubing is connected like this. Now see what happens to the pressure here. From here, this level up to the horizontal tube that is on a stand like that fixed. Up to this point, the height is capital H. I consider to the axis of the tube, the height. Then the pressure here, P2, is equal to PATM plus pressure due to the liquid. Pressure due to the liquid. That means water. Then PATM, atmospheric pressure, plus H rho W G. That is P2. Right? So then, wait. P2 must be marked here up to this point. P2. But when you consider the other point, because I marked here, is it confusing? I'll draw this here, the height. From here, H, up to this point. This is P1. We'll consider early method P1. Because first point P1, second point P2. P2 is exposed to the environment. This is PATA. Reason, this is B normally, we mark early method is concerned. B is exposed to the atmosphere. Therefore, PATA, pressure is equal to PATA. Then if you want to find delta P is called P1 minus P2. Cannot call, it is defined as P1 minus P2. P1 value is delta P is equal to P1 minus P2. P1 is PATM plus H rho WG. Any other liquid is there, that density should be considered, minus P2. P2 is also PATA. Then these two cancel off. Then delta P is equal to H rho WG. What do you call this instrument? Constant pressure head. Constant pressure head. This can provide, you can understand, because the water level doesn't go up but you have to adjust the tap according to this. If you open the tap widely, this goes up because the water goes through this tube to the sink is less rate, then it is having less rate. So therefore you have to adjust the tap until the water level is just stay in at the top of this tube, the corner tube. It cannot be below that, it cannot be above that. Should be at the same level. Until that, you have to adjust the tap. Right. This instrument can be fixed using a laboratory stand. There you marked it. Tube must be horizontal and it should be steady flow. When you are doing this, there's the Poiseuille experiment. There I will tell how to find the steady state. There what we do is, we consider this liquid should not eject like this, just like a projectile. From the end of the tube, it should really fall like this. Not like this, that is wrong. Until that, you have to adjust the height. If the height is more, under the practicals, I'll explain those. Now I'll tell you how. Normally atmospheric pressure, that means PATM value, is given as the height of mercury barometer. To find the pressure, normally we are using a barometer. Directly we can get the readings in certain apparatus. Normally barometer is constructed. There what happened, it's not a big thing. Normally 1 meter long tube is there. It is filled with mercury and it is to be placed upside down in a mercury ball. mercury. Ball means it's just like a beaker. Then the upper end is closed. Mercury falls and stay here. This is hydrostatics, but I will just remind you about this. Then here you get a vacuum. And mercury height to the upper point, meniscus is convex, and this is up to this point, the height is h. That is called barometer height. But you have to remember, you have to state the liquid, that is mercury, then mercury barometer. Mercury barometer, normally the pressure, atmospheric pressure changes place to place. Normally from the sea level, when it goes up, pressure reduces. If you consider Sri Lanka, it's in western province like that, sea level is really very close to the land level. So then when you're going to up country, the height reduces. So therefore, the pressure, atmospheric pressure reduces. That is there. But normally we consider the barometer normal height is H is equal to 76 centimeters of mercury or Hg. Then, but we can't apply this value directly for Poiseuille's equations or hydrostatics equation because SI units we have to use. Then what we do is we use normal pressure hydrostatics. In hydrostatics, pressure is equal to H rho G. So then PATM in this case is equal to 76 centimeters, but it should be converted to meters. 76 into 10 to the power minus 2 meters. Minus 2. If you want, you write the units here. Normally I don't write. Then density of mercury, 13,600 kilogram per cubic meter into G. G is normally 10, but actual value is 9.8. Right? So G is 9.8. Normally, it should be ms minus 2. We know that G is equal to roughly 9.8, 10, 9 ms minus 2 because acceleration. But in our papers, you see G is not given according to this. G is given according to the gravitational field intensity method. That means, in other words, F is equal to ma, you consider simply. A is equal to F over m. Force is Newton. Then mass is kg. Newton per kilogram. See your past papers or papers, A-level papers, normally they write G is equal to, they don't write 9.8, they write 10 approximately. Newton per kilogram. That is even in the MCQ where at the beginning it's there. Second paper also at the beginning it's there. Units, Newton, kilogram. You can use this one everywhere other than for the linear motion or rotational motion. Those places. Motion is concerned, use ms minus 1. Other places you use this one. Newton per kilogram. So look at this, what's happening. 76. Here, 13,600, no? 2 cancel out this one. Into 136 into 9.8 meters kgm minus 3 n kg minus 1. Then here it is equal to, you simplify and get the answer. Then kn Newton, kg minus 1 cancel off, m minus 2. This is pressure or Pascal. This is how you get the atmospheric pressure. Then just make a note. Atmospheric pressure sometimes given as a pressure of a liquid. Example. Atmospheric pressure is equal to 76 centimeters of mercury. Sometimes it is written as, then write, sometimes it is given as height of the mercury barometer is 76 centimeter. Same story. This can be given as height of water. Then write, this atmospheric pressure sometimes given as the height of water. Then it is called height of water barometer. Height of water barometer. That value is 10 meters. If it is given as height of water barometer, this is how you are doing. H is equal again, H rho G. Here we consider Hg. Here we consider water G. H is 10 meters, I said. Rho W is 1000 kilogram per cubic meter. And G is 9.8, then Newton per kilogram. From this you are getting 9.8 into 10 to the power 4. Then kilogram minus 1 plus 1 cancels off. Then that is equal to Newton m minus 2. Then 9.8 into 10 to the power 4. This one or Pascal. But sometimes if you consider G as 10 Newton per kilogram instead of this, then the answer is 10 into 10 to the power 4 Pascal or Newton. 10 to the power 5 Pascal, or sometimes 1 into 10 to the power 5 Pascal, or that is equal 1 into 10 to the power 5 Newton per square meter. So this is water barometer height is given. That is atmospheric pressure, not down. Right. Now, we'll consider, actually I did all those to get to a particular point with the Poiseuille's equation and the practical, because we want to find the pressure at the first end of the horizontal tube. For that, when they give in a question, then write example. In a Poiseuille experiment, that means which I drew early, the height between water level in the constant pressure head and the horizontal tube is 14 centimeters. Find the pressure at the first end, that is P1. Here you know that PATM is acting. P2 is equal to PATM. I showed it early. Then P1 is equal to PATM plus H rho G. 14, this is water. 14 into 10 to the power minus 2 into, this is H rho WG. This is 14 CL. Then converted into meters. Rho W is 1000. Then G is approximately 10. Then minus PATM, P2. So this is P1. Then P2 is equal to PATM exposed to the atmosphere. Then delta P is equal to this equation P1 minus P2. So PATM plus, here you are getting 14 into 10 to the power 2, right? Minus PATM. Then you get 1400 newtons per square meter, delta P. So Poiseuille's equation, if it is given like that, we are using a calculator and using according to this way. Application of Poiseuille's equation. First one, as an example, here you consider length of a capillary tube. Don't worry about the word capillary. Capillary means inside radius is smaller. Right? Capillary tube sizes will be given under surface tension. Now also I can give. So then, length of a capillary tube is 50 cm and it is fixed horizontally and connected to a constant pressure head. The height between the water level in the constant pressure head and the horizontal tube is 12 centimeters. Internal diameter of the tube is 4 millimeters. Coefficient of viscosity is 1.1 into 10 to the power minus 3 NSM minus 2. NSM minus 2. NSM minus 2. Number 1. Find the rate of flow of the liquid of water. Second one, find the volume passes through the capillary tube or passes through the tube in 5 minutes and 2 hours. Two separate questions. Last one, separately show the pressure gradient of the pipe. Now, first of all, what you have to do is, you have to find this one. This is the second paper answer. Then you have to use this 1200 comes. That is the first part. After that, you have to write the equation. This is whether you draw this or not, no marks and additional marks are there. But if you want, you can write like this P1, this is P2, like that. But delta P value is known now. Delta P is P1 minus P2. That is known 1200 Newton per square meter. And in this question, I gave NSM minus 2 as the coefficient of viscosity. Coefficient of viscosity, early we have given as how? Here NSM minus 2. That was given as NSM minus 2. So what is the difference? Can you understand what it is? Yes. So this is equal to Newton is kg m, then s minus 2, then s, then m minus 2. Then you get kg, this is 1, m minus 1, s minus 1. This is what I gave earlier. Eta. Or in other words, eta is given as kgm minus 1, s minus 1. If they ask to convert this to nsm minus 1, what you do is kg, then we want to get m, s minus, we want to make it newtons. To make this one into Newton, I have to write, or I have to consider m s minus 2, kgms minus 2, but I can't add like this. So therefore, I am writing below ms minus 2. Then both will cancel off. Then you get original m minus 1, s minus 1. Then this can be written as Newton. Then this is taken up. It will become m minus 1, again m minus 1. The red one goes up, then m minus 1. Then s minus 1, red one goes up, s plus 2. But the black one is s minus 1. Then you get n m minus 2 s. Normally n s m minus 2. That is how it comes. First of all, whatever you want, note down. Now, in this question, we found delta P. Now we want to write the other thing. Then you write A. A is given as, I have given D diameter 4 millimeters, which is equal to 4 into 10 to the power minus 3 meters. Then A is equal to D by 2. Therefore, 4 into 10 to the power minus 3 divided by 2 meters. 2 into 10 to the power, that means 2 into 10 to the power minus 3 meters. Then eta, 1.1 into 10 to the power minus 3, ns m minus 2. Then delta L. Delta L, the pipe length is given as 50 cm. That is 50 into 10 to the power minus 2 meters. It should be in meters. Then according to the Poiseuille's equation, Q is equal to pi by 8 e to the power 4 delta P divided by eta L. But here I'll consider L, not delta L, because I wrote the equation in that way. So then now pi is known. Pi is 22 by 7. Then you can substitute. This is called correct substitution. 7 into 8 into 1.1 into 10 to the power minus 3 into 5 into 10 to the power minus 2, 50, sorry. 50 into, then A is written as 2 into 10 to the power minus 3 to the power 4. Delta P is 1200. Then you have to simplify. Then you are getting, I'll do halfway, 22. Then 2 to the, this is 1, 1 into 4. 2 to the power 4, 10 to the power minus 3 into 4, 12, 1200 divided by 7 into 8 into 1.1 into 10 to the power minus 3 into 50 into 10 to the power minus 2. 2 to the power 4 you have to obtain. 2 to the power 4 means you have to multiply 2 4 times. 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16. Right? So then this can be written as now 22 into 16. Now you can consider 7 into 8 into 1.1 into 5, or you can say 50 if you want. Now you can take this one. Then here you get 10 to the power minus 12. Wait. 16 into 12 into 10 to the power minus 10. Because these two I consider them cancel off with 10 to the power minus 12. That means you are getting only 10 to the power minus 10. Then this one is taken up 10 to the power 3. And here 5 is or 50 is there or 5 is there 10 to the power minus 1 taken up 10 to the power then 1. This is how you are getting it. You can simplify further 8 into 2. Like that, simplify and get the answer. Answer comes in cubic meters per second. Come up to that point. Right. Next part I am asking for 5 minutes and 2 hours. The amount, that means the volume, passes through the tube. So then Q is found. After that, what we will do is Q is equal to V over T. So Q is found from here. Then after that, for 5 minutes, T is equal to 5 minutes. But you can't use 5 minutes in second, 5 into 60 seconds. This should be substituted there. Then V comes in cubic meters. For 2 hours, T is equal to 2 into 60 into 60 in seconds. So that should be again substituted there and find the other volume. Q is known. Note down quickly. We are jumping to another one now. Right. Now we'll plot a graph delta P versus L. Then write the graph delta P versus L. That means pressure difference versus the length of the pipe. Delta P versus length. But anyhow, we'll consider this equation as Q is equal to pi over 8 eta L a to the power 4 delta P. So delta P is equal to Q 8 eta Q into L divided by pi a to the power 4. Coefficient of viscosity depends on the temperature, but temperature is constant. Normally temperature increases, coefficient of viscosity decreases. We'll discuss further in the other future section. So then normally temperature is constant if now eta is a constant, pi, a all are constant a to the power 4. Then Q is rate is a constant. So therefore, this is delta P is equal to K dash L like that. Y equals mx like that if you, but Q changes according to the length. That's also there. So normally we consider delta P over L without using this because Q we can't say directly. But we know G, curl G is equal to delta P over L. Then delta P is curl G into L. Like that. So the pressure gradient like that it can be. So those things we can consider. Then normally the graph comes like this. According to the length of the tube, here length is of the tube. So then tube starts from initial place, length is 0 like that then. But anyhow, that time the pressure at that end is P2. P2. First end P1. P1, P2. Length is 0, P1. Length is P2. That is P80. P2 is P80. So then this is P80. Then the length of the pipe is L up to this. L. Then this set. The pressure changes according to this straight line. This value is equal to P80. This is actually pressure gradient graph. Don't try to get anything from Poiseuille's equation, just get it from here. The reason is Q is not always the same. This is length of the pipe, pressure, actually the difference comes like this. This is the pressure P1, at the P2 it is P88. This difference is P1 minus P2. Now we'll come to combined tubes. Then write combined tube. Or sometimes we say composite tubes. That means two tubes are connected together. We'll consider one tube like this. The second one is having less diameter. Only the internal part is drawn. So here the common axis. This is A1. Here the pressure is P1 or PA. This is A, this is B, this is C. Here PB, pressure. Here pressure is PC. Length is L1 here. This is L2. Same liquid flows through that. So therefore, eta, this is also eta, because same liquid. Now, such composite hulls, tube is concerned. Here also, the liquid should flow according to the steady situation. Or it's a steady flow. Then what happens is, there is a rate of flow through AB. There is a rate of flow for the liquid through BC. Normally, no liquid can be stuck inside. So it should go through the tube out itself. So therefore, the rate of flow through the first part of the tube, that means QAB, must be equal to rate of flow of liquid through BC. According to that, pressure at B edges, it changes according to this one. To satisfy these two rates are equal, the pressure at the common point edges. Then draw it and write it. So then we can write for QAB, because we are using Poiseuille's equation, QB is equal to pi a to the power 4 delta P divided by 8 eta L. Delta P changes. Then QAB, for AB we are writing. QAB is equal to pi A1 to the power 4 delta P for AB. That means PA minus PB. Delta P here is for the first part PA minus PB, because it flows from higher pressure to lower pressure, divided by 8 eta L1. Then you can write QBC for BC. Pi A2 to the power 4 A2 to the power 4. This pressure difference is PB minus PC divided by 8 eta is same L2. Then since the rates are the same, we can equate these two. QAB is equal to QBC theory. I wrote it again because at the exam You had to start from here. So we are not writing these things earlier. So then we can say pi a1 to the power 4 pa minus pb divided by 8 eta L1 is equal to pi a to the power 2 to the power 4 pb minus pc divided by 8 eta L2. Now 8 eta cancel out. Pi cancel out. Then normally you get PA minus PB divided by PB minus PC, this was taken down, is equal to L1 over L2 into A2 to the power 4 over A1 to the power 4. Or in other words, L1 over L2 into A2 over A1 to the power 4 is equal to PA minus PB divided by PB minus PC. For MCQs, sometimes they ask question according to the pressure differences and the length. So in the question, certain needed details are given. For instance, first one will say you have to plot a graph, the pressure difference or pressure versus the length of the tube. Then first one, L1 is greater than L2 and A2 is greater than A1. Second situation, L1 is equal to L2, A2 is greater than A1. Both are equal. A2 is greater. Third one, L1 is less than L2 and A2 is less than A1. Fourth one, L1 is equal to L2, A2 is less than A1. I can give some more, one or two situations I'll explain. L1 is greater than L2, A2 is equal to A1. Sixth situation, L1 is less than L2, A2 is equal to A1. Those are easy. The last one is not to be considered actually. L1 is equal to L2, A2 is equal to A1. Note down. Plot a graph for composite tube. Plot a graph, or better say sketch a graph. Sketch a graph for the following situations for a given composite pipe as drawn in the diagram. But this situation diagram is not common always. L1 is greater than L2, A2 is greater than. For this situation, this is drawn. I think you have completed this. We'll consider the first situation. You can draw later the other things, or one or two I'll explain. So then P1 minus P2 or PA minus PB divided by PB minus PC is equal to L1 over L2 into A2 over A1 to the power 4. This is the equation we obtained. Finally, you wrote it and we got this equation. I wrote it there and erased that time. Now conditions are considered. Now L1 is greater than L2. This condition. That means L1 over L2 is greater than 1. Now A2 is greater than A1. That means A2 over A1 divided by this greater than 1. You divide both sides by A1. So this can be obtained A2 greater than A1 divided by A2. Then you get divided by A1. Then A2 over A1. A1 over A1. That means 1. Like that you get this. If it is so, A2 to the power 1 to the power 4 is greater than 1 to the power 4. 1 to the power 4 is 1. Any power is of 1 is 1. So now we can multiply these two. That means L1 over L2 into A2 over A1 to the power 4 is greater than 1 into 1. That means greater than 1. This is the one I wrote it here. This is equal to PA minus PB. Therefore, PA minus PB minus PB minus PC. That means PA minus PB is greater than PB minus PC. Right up to this. Then after that, I'll draw and show you. Sometimes students try to remember these graphs. It's difficult because always try to get quickly you get it as an equation. You can do it within 30 seconds like that. But for normally, generally for MCQs, more than 2 minutes is there slightly. So therefore, you can come to the conclusion quickly. It's difficult to remember those things. Some students can remember, but the thing is capacity is concerned, it's less, no? Just like a hard disk. So then when you are loading more and more, the other things cannot be stored there. Sometimes the speed also getting reduced automatically. It reduces automatically. Right. Now according to situation, when you are plotting the graph, this was our situation. According to that, you have to draw the graph. Sometimes they draw the combined or composite tube. But here, the axis is like that. Now the problem is you can't see here. Can see up to this. Okay. So then here remember L1 is greater than L2. L1 is greater than L2. That was one condition. So this is, I started from this end and can go up to, can see. Here up to this point we had to draw. Axis can be there, but you can't draw the graph beyond this. Now we know that PC is atmospheric pressure. According to this, PA minus PB difference must be greater than PB minus PC. This PC is PATM because exposed to the. So we'll see PATM is here. Now we'll mark L1. Up to this, or this length is L1. Up to this L2. So therefore L1 plus L2. In other words, this part is L1. This part is L2. Now, this is PATM of PC, which is equal to PATM. Now, that is the end of this. This side must be there. You have to put that dot there on cross. Then, PB minus PC difference must be smaller. Then PB is here. PA must be somewhere here. Now PA minus PB difference is this greater than this. So therefore PB must be marked somewhere here. Now your graph is concerned, it's like this. After that, so this should be the point where you get L1. This is L2. Like that, clear inclination differences should be shown. These are normally given to the MCQs, but there are situations early, very old papers or past papers. Even for the first one, it was given. But now they don't give. Most of the time you get for the paper 2. Now I'll consider another situation, number wise I can remember. There was a situation L1 is equal to L2. And A2 is greater than A1. That situation also the same. Because here the difference is now L1 is equal to L2. See, L1 is equal to L2. So therefore, we have to consider only this part. We are getting the same thing. But in this case, this is correct for this also. But only the difference is L1 is equal to L2. This is L2. Not L1, I have drawn there is L1 there also. This is L2. Now in this case, both are equal. So that means this is up to this L1 and the other part L2. That is also the same distance. L1, L2 same. So then PC must be here. Then PB must be there. Then this is the new graph. This situation. Like that, you just think and draw it. Wait. This inclination should be drawn properly. This situation for this. Like that, other things you can try. Draw and see. You get the correct answer. Now I gave you the proper method. Right. Another example. Remember, you can't draw up to this because atmospheric pressure is there. It has a certain value. So therefore, the last point should not come to onto the x-axis. Then write this question as an example. For example, or for instance, two capillary tubes, diameter 4 millimeter, length 50 cm, and diameter 2 millimeter, length 20 centimeter are connected in series. In series means one alone, same axis should be there. Water flows through this and the pressure difference between the two ends of the composite pipe is equal to 14 centimeters of water. Find the pressure difference in each part of the tube. Each part of the tube. Second paper, normally, you consider first A to B or AB. Then we can use Q equals Poisson's equation, pi A to the power 4 delta P divided by 8 eta L. Then the first situation, QAB is equal to pi A1 to the power 4 PA minus PB divided by 8 eta L. Eta value is, get the eta value. Eta is equal to 1.1 in 10 to the power minus 3. Ns m minus 2. You can substitute for A1. You can substitute for L1. So that means A1 is equal to 4 divided by 2 into 10 to the power minus 3 meters. L1 is equal to 15 to 10 to the power minus 2 meters. Like that you can substitute there. But again you write for QBC. Then 5 a to the power 2 to the power a2 power 4 PB minus PC divided by 8 eta L2 is equal to this. Then A2 is equal to, you can substitute it, 2 by 2 into 10 to the power minus 3 because I gave the diameter. That is the reason I divided it by 2. And L2 is equal to 10 into 10 to the power minus 2 meters because it was given in it was given as 20 centimeters. Centimeters are converted to meters. I have to multiply by 10 to the power minus 2 or divided by 10 to the power 2. Now, since the rates are you are right. Since the rates through each tube is the same, you are right like that. That means QAB is equal to QBC. Statement is needed even you write this and you equate these two. When you equate these two, you get the equation as pi a to the power 4, but those values are substituted with C, PB, 8 eta L1 is equal to pi a to the power 2 PB minus PC divided by 8 eta L2. So as I did early, you can cancel off this. And finally, you get a certain equation PA minus PB is equal to a to the power 2 divided by a to the power 1 to the power 4 L1 over L2. Actually, this simplification was done by me early in this way. These values are substituted. And PB minus PC. You get a value for this. Some value. Now, we want to get, they are asking the values. They are asking what? They are asking the pressure difference PAB value and PBC value. We want to find. Do up to this. You substitute the values and get this equation. Here you are getting a value here. After this, you do like that. Then I'll tell you what to do. After that, you have to get the other detail which I gave. That was the pressure of the two ends of the pipe, composite pipe. PA minus PC is equal to 14 cm of water. That is H rho G. So H is 14 into 10 to the power minus 2 in meters. Rho is 10 to the power 3. Then G is 10. I did the same thing like earlier. And then I got 1400 pascals or Newton per square meter. Right? So then that's there. In other words, PA minus PC is equal to 1400. Now you have a problem. Here, PA minus from here, PA minus PB is equal to certain value into PB minus PC. Right? This value is some value, numerical value. Now, you can subject PC or minus PC. We'll say minus PC. Minus PC is equal to 1400 minus PA. Understood? This is kept as it is and PA is taken to other side. Then, look at this. What I'm going to do now. Here, BA minus PC. For that, I'm writing 1400 in red, I'll write. 1400 minus PA is equal to that particular value. For instance, we'll say value is 5. That's not the value. It may be a different value. We'll say 5. This is wrong. Then PB minus PC. Now see what's happened. PA minus PA cancel. Then PB minus PC is equal to 1400 divided by 5. This is a wrong value. You have to get it. Then you can find PB minus PC. When you know PB minus PC, this is known, then you can find PA minus PB. This is known. That is how you are getting the answers. Right, next. Now you can find two values. Then note down this question. The water supply to a certain house consists of a horizontal water main 20 cm in diameter and 5 kilometer long to which is joined a horizontal pipe 15 millimeters in diameter and 10 meters long leading to the house. Draw leading into the house. Full stop. When water is being drawn, BEING, when water is being drawn by this home, this house, not home, this house only, that means the other houses are not drawing water that time. What fraction of the total pressure, what fraction of the total pressure drops along the pipe appears between the ends of the narrow pipe. Assuming the rate of flow of the water is very small. Here you might think why it is given like that. The reason is suddenly the pressure. Once I said when they are in the last video. So when we consider, if you consider the pressure suddenly changes in a pipe, even a composite pipe, the pressure differs, then the flow won't be steady that time. Even the pressure difference is very high, that is not steady flow. That is the reason they are saying pressure differences are small. And here the equation was true for the composite tubes or pipes when they are in series. Series means in the same line. But here, even it is perpendicular like that, we can apply. Then note it down. Normally, Poiseuille's equation is applied for composite pipes for composite pipes in series. But even differently bent pipes we apply to obtain the needed values. This is not exactly correct, but we apply. That means this is A, this is B, this is C. Here also PA minus PB, right? So OQAB is equal to QBC. Same theory can be applied. Not the discussion I'll do. Next one. There are situations several pipes are connected. So we'll say two pipes are connected. Two pipes or three pipes or whatever the value. One pipe, another pipe connected to one bigger pipe like this or shorter one. This is A, this is B, maybe A, B, we'll consider this is B. This is C, this is D. Then QAB, the rate through this plus the rate of flow through QCB is equal to QBD. This rate plus this rate is equal to this. You have to mark the pressures according to the given way. Here, this practically, normally, we'll say crude oil is brought to a country, or the purified ones, refined ones. Whatever it is, this is a main pipe from the harbor. Actually, most of the situation in the harbor you don't get. Outside the harbor, large buoys are there. From that, the pipeline is directly connected from the tanks in the ship and directly pump. They don't normally, ships do not come to the harbor. Floating ones are there. In Sri Lanka also there are two. Then what happens is the oil comes, then there are two lines. One goes to one refinery, other one goes to another refinery. Same one. QDB is equal to then QBC plus QBA. If it flows here, it will flow like that. Your diagram, it should be like this. Draw like this. And you wrote it now. Second diagram, again you draw the same thing, but arrowhead is from the other way. Then QBB is equal to QBC plus QBA. It's coming the opposite way. Then you write the Poiseuille equation for this one, and use this equation. Then you get the answer for that. If several pipes are there, even not horizontal like that, after that, another two pipes are there like that. A, B, C. This is D, E, F. Then the liquid comes like that. Any direction it can be like this, and moving away, flowing away. Then we can say QAD plus QBD plus QBCD is equal to addition of incoming flows, rate of flows, is equal to outgoing rates. QDE plus QDF. Like that you can write. But we proved actually when it is in series, but we cannot. Right. Now, the question which I gave as some water supply to a house like that. The long pipe is there. Its diameter is larger and it says 50 kilometers, something like that. No, 5 km. 5 kilometers, 5,000 meters. 5 kilometers. And its diameter is given as diameter, this is 10 cm A because diameter is 20. After that, it goes like this. After that, it bend and goes to the house. So then capital A, capital B, then house is here C. C. Here the diameter is 2. Second one, 15 millimeter and 10 meter long. This is 10 meters and this is diameter 15 divided by 2 millimeters. 15 divided by 2 millimeters. Now, same theory you apply, then QAB is equal to QBC. They are asking what is the drop of the total pressure. Then you will write the value for the total pressure and get it. Yeah, this is the way. Now you write certain equation for QAB. Pi, then A1 to the power 4 PA minus PB over 8 eta L1. Then QBC is equal to pi A2 power 4 PB minus PC divided by 8 eta, eta is the same L2. Then you write QAB is equal to QBC. This is not needed, no, I'll write it here. QAB is equal to QBC. Then you get a certain equation. After that, QAB is the total pressure. This is called total pressure because main line pressure. That is total pressure. Then you get a value P. They are asking the drop normally. What you want is you get a value for PB minus PC divided by is equal to certain value into PA minus PB. They are asking this fraction. What is the drop? This is the total pressure. This is equal to, we'll say this is 1.5, 1 divided by 3. then this is the total pressure. So then if this is 1,3, this is total pressure. So then total pressure 1/3 is the fraction which is dropped. That's all for this section. Under Poiseuille's equation, all the type of applied applications are explained. And most of the time you can really directly, after doing certain questions, you can directly go to past papers and do.